Good morning, dear students. How are you? Today we will discuss RDOE worksheet 47 from your chapter Classification of Elements. And today we will discuss how the elements are placed in case of modern periodic table. The position of elements in modern periodic table. The modern periodic table has 18 vertical columns. Vertical columns means like this. They have 18 vertical columns and 7 horizontal rows, and these 7 horizontal rows are called as periods. Okay, and these vertical columns are known as groups. Okay, so we have 18 group and 7 periods. So students, vertical columns. If we take the elements of group 1 of the modern periodic table and write the electronic configuration of the first 3 elements of group 1, we have first element in group 1. If we will talk about group 1, then we have hydrogen, atomic number 1, so electronic configuration 1. Likewise, we have lithium, atomic number 3, and electronic configuration 2 and 1, and sodium, electronic configuration atomic number is 11, electronic configuration is 281. So what is the similarity? If we'll see, in the outermost shell we have 1 electron. Okay, and this is, we are talking about group 1. So this is the similarity. If we take the example of the element of group 1, they all have the 1 electron present in the outermost shell. So what are the similarity do you find in the electronic configuration? So we find that all the elements contain the same number of valence electron, right? And next we have how many valence electrons are present in these 3 elements. So as we have seen this 1 1 1 in the uh, uh, outermost shell electron, we have only one electron, so 1 electron is there in their valence shell. So the element present in any one of the group have the same number of valence electrons. Means if we move from up to down in the group, the number of valence electron remains the same, whereas the number of shell increases. See, in case of this first element, we have one shell. In case of lithium, we have 2. In case of sodium, we have 3, and in case of potassium, we have 4. So the number of valence electron is equal to number of the group. Means if we are talking about first group, then in first group, valence shell electron, the number of valence shell electron is 1 in all elements from as we move from up to down. So number of valence electron is equal to number of group. See this example, the number of shell increases as we go down the group of the element. See, lithium, the atomic number is 3. Electronic configuration is 2 and 1. Sodium, we have 11. 2, 3, 8. Potassium, we have 2, 8, 8, 1. This is the structure of lithium. This is sodium and this is potassium, right? And likewise, if we will talk about horizontal row, which you call as periods also, and we have 7 periods in our modern periodic table. So if we take the example of this second period, that is lithium, as we move from left to right, we have element in the second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So what is the similarity? They all have Number of shell remains same in all elements. The number of shell remains the same as we move from left to right. See the see the atomic number of lithium is 3. So K and L we have 2 1. If we talk about beryllium, 4, 2 into 2. If we will talk about boron, it has 5, 2 and 3. If we talk about carbon, 6, that is 2, 4. If we talk about nitrogen, so 2 and 5. Likewise, C. And if I'll talk about the oxygen, 2 and 6. If I talk about chlorine, it is 2 and 7. So what is a common? The number of shell remain the same as we move from left to right in a period. So do these elements contain the same number of valence electron? No. Valence electron is increases with the unit value, okay, with one number as we move from left to right. See, 1 2 3 4 5 6 7. So the number of valence electron increases with the unit value, means 1. Do they contain the same number of shell? Yes, they contain same number of shell. These elements of the second period do not have the same number of valence electron, but they contain same number of shell. This is the answer of this question. The number of valence shell electron increases by 1 unit as the atomic number increases 1 unit on moving from left to right, as you move from left to right. Number of shell equals to number of periods. Okay, as we discussed this is, we have total number of shell 2. So in case if we talk about the period, then it is second. They all elements are placed in the second period. Okay, the atom of different element with the same number of occupied shell are placed in the same period, like sodium. This is, we are talking about third period. We have sodium, then magnesium, aluminium, then we have silicon, phosphorus, then sulfur, then chlorine and argon. So atomic number is 11, 12, 13, 14, 15. Okay, sulfur, this phosphorus we have 15, sulfur 16, chlorine 17 and argon 18. So this is, we have third period, and as we move in this, they belongs to third period in the modern periodic table, and since the electron in these atom, in the atom of these element will KLM shell, like KLM shell, the maximum number of electron shall be accommodate depend upon the formula 2n square. So this is the example. If we talk about K shell, this is the first. So K shell is the first shell. We have 1 2n square. So if we take 1, then we have 2 elements. Maximum number of 2 elements are there in this shell. Next we have L shell. L we have 2 into 2, 2 into 4, that is 8. Next we have, if we talk about the third period, we have 2 into n square, that is 2 into 3 square, then 2 3 into 3, that is 18. So the third, fourth, fifth, sixth and seventh period have 8 18 18 32 32 elements respectively. So this is all about your today's worksheet. Let's So let's do beta practice exercise. First question, we have element like fluorine and chlorine belongs to 17 group. How many electrons do fluorine and chlorine have in their outermost shell? So if we're talking about fluorine at the atomic number of fluorine is 9, and uh, chlorine atomic number is 17. So electronic configuration 27, whereas in case of chlorine electronic configuration is 287. Okay, and they both have outermost electron. The number of outermost electron is 7. Okay, they have 7 valence electron in their outermost shell, right? This is the answer of your first question. Second question, we have write the electronic configuration of magnesium, aluminium and silicon, to which group and period they belongs to. If the atomic number of magnesium, aluminium and silicon is 12, 13 and 14 respectively. Let's do this question. If we're talking about the magnesium, we have electron atomic number is 12. So electronic configuration is 2A2. If we're talking about aluminium, electron atomic number is 13. We have electronic configuration 2A3. If we talk about silicon, the electron atomic number is 14 and electronic configuration is 284. So see, all these have number of shell. They have 3 number of shells: K, L, M, K, L, M, K, L, M. They all belongs to the third period. They all belongs to third period, right? Whereas in case of period, in case of group, they all belong to third period because of the number of shell, that is 3, but they belongs to group second. Magnesium belongs to group second. I'll write it for again for you. See, if we will talk about magnesium, aluminium and silicon, we have electronic configuration 282. This is we have 283, and in case of silicon we have 284. So if we talk about period, they belongs to period magnesium and group magnesium, aluminium and silicon, they all belongs to third period, whereas they belongs to magnesium belongs to second group and aluminium belongs to 13 group and silicon belongs to 14 group, right? Next we have write down the electronic configuration of first 3 element of the group 1. This is the answer of your question. Write down the electronic configuration of first 3 element of the group 1. What similarity do you will find in the electronic configuration of these elements? So if we talk about the similarity, they all have one electron, their outermost electron in their outermost shell. They all have one electron in their outermost shell. So answer of your third question. How many elements are there in the first, second and third and fourth period? Okay, first period we have we have 2 element. Second period we have 8 element. Third period we have 18 element, and fourth period we have again. See, if fourth period we have again, if we talk about 18 element. See, fifth question, how does the electronic configuration of an atom relate to the position of modern periodic table? According to the modern periodic table, elements are arranged according to their increasing number of atomic, increasing order of their atomic number. Whereas in case of mentally periodic table, elements are arranged according to their increasing atomic masses, and in case of modern periodic table, elements are arranged according to the increasing order of their atomic number. Okay, so this is all about your today's worksheet. I hope you understand it very well. And so if you really do, like, share with your friends and subscribe the channel. Thank you, students. Take care.